recording on today's session. Okay, so the topic we were discussing yesterday, we were talking about the OSI layer, right?
Yes.
Yes.
So we have the application layer, we have the
Presentation and session.
presentation, session, we have transport, we have the network layer, we have data link, and we have the
Physical.
physical layer, numbered in this order. So as we discussed yesterday, the application layer has a bunch of protocols, right? Namely the application protocols like HTTP, SMTP, and all those guys.
Yes.
So anytime an application requires network access, it approaches the application layer. Specifically, one of the protocols which has setting there. Now, which protocol to approach is, of course, is programmed into the application, right? For example, a browser uses HTTP that is pre-coded into the application itself. So
Yes.
it is the programmer who decides which protocol it's going to use, depending on what its function is.
Yes.
And once it does that, it moves down. The request moves down to the presentation layer, where it does the format conversion. It does a little bit of encryption, and it does a little bit of compression, right?
Yes.
And then it moves down to the session layer. So as we were beginning to discuss yesterday, session layer was a very important layer at one time, because session layer's primary job was what we call end-to-end connection, right, or host to host. Basically, session layer makes sure that the machine you are trying to contact has at this point of time the resources to either accept your query or reply. For example, when I'm trying to say call you, make a telephone call to you, right? You might have set your phone on a busy mode, right? Because you are doing something, or you might be talking to somebody else, which means the connection would not be established, right?
Yes.
See, this is not very relevant today, because if you talk about when I started out, I mean, um, let's say my first computer back in say 89 or 88. Can you by any chance guess how much? What was the processor that computer had? How much RAM it had? And what was the hard disk size? I'll give you three chances to
Mm,
guess.
I guess her drive size is in bytes.
Okay,
Uh,
give me a number.
mm, Usually means on the means in past they use like floppy drive
Hmm.
to access OS. I mean to run OS on the computer,
Hmm.
and RAM might be in bits.
Well, not that bad, but close. The processor, one of the machines had a X386 processor, right? I had an amazing amount of RAM, 64 kilobytes, and I had a zero hard disk, because, as you were saying, we did not have, because those days the machines were XT machines, extended technology, which did not support a hard disk. What we use today is the advanced technology machines which support storage. So when you think of a machine like this, my smartphone probably is 100 times, maybe more capable than this machine, right? Because my smartphone, the one I'm carrying now, he's got one of those octa-core processors. He's got 4 GB of RAM, right? It's got 64 GB of storage. So I'm sure if I keep my that big dabba of machine I used to use back in '89, or the one on which I learned, and my phone, I mean, my phone would probably look like the Hulk in terms of processing power, right? So
Yes.
with machine like this, I mean, say I am sending a request to get a file from here, and he might start servicing it. Somebody else might do the same thing. And when a third person comes in here, this guy probably does not have the resources to answer or supply whatever he requested, right?
Yes.
This was the primary function of the session layer. Before the session is established, the primary session layer makes sure that this guy is now available to service your request. So that's why it creates what we call a end-to-end session. So creating end-to-end sessions and tearing them down after the transfer is done was the function of the session layer. And it's obvious that in today's world, this is not much relevant, right? I mean, even your basic laptop can actually serve probably a few hundred connections at a time.
Yeah.
And you're talking about your web servers, then those we are talking about multi-core, multi-processor models with literally terabytes of RAM and I mean petabytes of huge storage behind them. So I don't think a session layer would have much to do at this point of time. And again, um, most of the servers are load balanced, which means you have multiple server clusters, right? And before the suppose a million people are accessing the Google server at this time. Do you think one server is handling all that?
No.
Obviously not, because Google will have, even in one location, they will have a bunch of servers replicating and synchronizing with each other. And you would, of course, have some sort of a device which is load balancing, right? This would be a
Yes.
load balancer. So the first, like say, 1,000 requests, it is going to send to this machine. And then the subsequent 1,000 which comes in is going to send to the next machine. And the third one is going to do that. So this device is taking care to make sure that these machines don't get overloaded. Got it. So session layer as
Yes.
is not very relevant today, right? And again, we don't worry much about these three because these three are pre-implemented in the operating system and they are non-configurable. So unless you and me are an operating system developer, there is nothing for us to do here. So as a network engineer, we need to understand what they do, but nothing more. Because none of these layers, you or me can do any kind of a configuration or tuning, right? As a network engineer, our entire game is going to be played in these layers. Even the physical layer, we don't really concern much because that's going to be the job of a technician to do the cabling part, right?
Yes.
Because the physical layer is going to be concerned with mostly cabling and the devices, which of course we are concerned with. So transport, network, and data link, and data link also not so much on that, but these are the two layers in which the entire networking and security game is played in. Understanding these two, especially transport layer, that is where most of the security games are played. So these two layers are going to be of primary importance in all through your career. This not so much, but still there. This practically nil. But you need to understand protocols, which protocol goes with which application, right? So that you can troubleshoot or provide security for it, right? So let's start off with now. You understood what the first three layers functions are, right?
So your voice
Sorry? Hello?
or your voice was dropping. You're breaking up.
Oh, okay. Hang on a second. Let me just quickly do a speed test and see if I'm having a problem. Speed test wouldn't do much. sense right now because application. Hello?
Yes.
Yes.
Yeah, I don't think it's a speed problem at my end because I'm getting a steady 25 MB at my end. So if there's a problem, it could be on the server itself. Are both of you facing the same problem? Voice drop?
Yes.
Yeah.
Even now?
Better.
Okay. Mm, bandwidth doesn't seem to be a problem from my end. Hello?
Yes.
That's much better.
Oh, great. All right, so you understood the functions of the first three layers, or rather the top three
Yes.
layers.
Yes.
Yes, sir.
Now, we're going to talk in detail about the transport layer. What do you think is the function of the transport layer?
Transport layer, like transporting data from a PC or from a user to another.
That would more likely be the function of the network layer.
Oh.
Between machines, between locations, that would most probably be the network layer where the IP protocol itself runs. Here, in terms, transport basically means you are, because see, at any point of time, there are multiple applications accessing the network, right? I mean,
Mhm.
you might have your browsers, multiple windows accessing either the same website or multiple websites. I mean, we all have the habit of opening up multiple tabs or multiple windows and accessing, doing different searches on Google.
Mhm.
At the same
Yes.
time, you might be having some sort of a, say, video chat open in one side. You might be sending you and downloading your mail also, right? So from the same machine, you are doing multiple access to the. So somebody has to be in charge of keeping these separate, right? Because if you don't keep
Mhm.
all these streams separate, what will happen is the request which goes from the voice chat, the reply might come back to the browser,
Mhm.
right? Because from the same machine, there are multiple streams of communication going outwards. So the incoming or the reply for all those has to come to the right application, right? So that is one of transport's primary jobs. But let's look at it in a different way. Now, what are the two primary protocols at transport layer?
What are the two what? Sorry.
Primary protocols which function at the transport layer. You heard of both these protocols, right?
Yeah.
TCP and UDP.
Yes.
All right. Now, do you remember the full forms?
Uh-huh.
So TCP stands for,
Transmission control protocol.
and the UDP
I don't know, but UDP, I think it's for voice, right?
also for voice.
Uh-huh.
That would be transmission control protocol, and this would be the user datagram protocol. Now, do you think both of them perform the same function, or they do have they have different functionalities?
I think same.
If you remember the definition of the OSI, it says that it groups protocols based on their functionality, right? So typically, if you look at it, most of the protocols at a certain layer perform more or less the same functionality, correct? So in this case, TCP and UDP both perform a very similar function. Only thing is that they do it differently. All right. Now, if you look at the major differences, one, TCP we call a connection oriented protocol, and UDP is a connectionless protocol. Any idea what that means?
What is that connection? What?
Oriented. Pardon my handwriting. It's been terrible all along.
Yes.
Let me write that again. Better?
Mhm.
Okay. So what do you think that means? Connection oriented and connectionless.
UDP connection less.
Yes, meaning no connection.
Oh.
See, connection oriented here means, let's say, if I come into the class today, and normally how do we start a class? I mean, we kind of greet each other, we talk about a few things, right? Make sure that both of you are there, both of you are ready to listen, right? Then we start the class, correct?
Yeah. Everything is all connected.
Correct. What if I just come into the class without bothering to look whether you guys have actually logged in or not, and the names I just start. Okay, today we're going to talk about TCP/IP and blah 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 blah. Finish the class, close it off, and walk away. Right. So I'm not sure that you guys are even logged in. Right. I'm not sure if you're logged in. Your audio is active. Right. I'm just without any connection between you and me. I'm just taking the class and going, assuming that you are there, and that you're listening and you're interested in whatnot. Right? So this is what you mean by connection oriented. TCP, before it actually starts sending any data to any destination, it establishes a connection with that client or with the destination. It makes sure it is there. It establishes certain parameters of transmission, and then starts sending the data. Does that make sense?
Yeah.
Yes.
So let's say you have your machine A and your machine B, right? So what TCP would do is, first of all, because you think about it this way, this machine is capable of transmitting at say gigabit speeds, 1000 MB, while this machine is capable only has a 100 MB network card. Now, what would happen if this machine is going to just pump data out at 1000 Mbp per second? What do you think would be the result?
It get overload.
Correct. Which means this guy would not be able to accept that. He would accept 100 and the 900 MB would be dropped right here, right?
Yes.
It doesn't make much sense. That would be the result of connectionless functionality. What A would do first of all is establish a connection to B and say, okay, are you there? Are you ready to accept some data from me? So B says, yes, I am ready. Okay. And A says, listen, I am capable of transmitting at 1000 MB per second. What about you? B says, sorry, no can do. I only have a 100 MB capability. So both of them agree then. Okay, let's transmit and receive at the common capability, which means 100 Mbps. So you understand that is part of it. There is a dialogue, there is a communication, there is a negotiation before the data transmission actually takes place. All right. And the way it is done is A sends what is called a SYN or a synchronization request, right? With all the capabilities, all his capabilities. Got it?
Sir, can you simply define the synchronization? Like, what is the meaning of synchronization here? Like, it's sending or receiving, or just the process of sending or downloading or uploading?
No. Any kind of communication that is to be established, before doing that, if A wants to send data to B, the first step is to establish certain parameters, right? Or
Mm-hmm.
common capabilities. So what A would do is it would send a what is called a SYN packet or a synchronization packet, which basically contains all his capabilities,
Mm-hmm.
the speed at which he can transmit and all those things, right? So if B, now synchronous is a packet, it's a packet of data which has all the details, which is
Mm-hmm.
both a packet for information as well as a query. So if B is ready and is listening, what would he do? He would reply back with a SYN packet of his own and an acknowledgement for A's synchronization request,
Mm-hmm.
right? Once that happens, A sends back a final acknowledgement. So now A has sent his capabilities, B has acknowledged that, and he has sent his own capabilities. Now both of them know what they're commonly capable of, right?
Mm-hmm.
And A and B both know that the other machine is alive on the network and listening.
Yes.
Now it is at this point of time that data starts to flow after establishing the common parameters there. This process basically is called a three-way handshake because there are three steps involved in it, right? Have you got that? Hello?
Yes.
No, no. What is the problem? Is it the audio problem or you haven't understood it?
The audio issue, it's breaking up.
Okay, that is going to be a problem. Let me try reconnecting to the network, guys, because I'm not really seeing a bandwidth problem on my end.
All right.
Hang on a second. I'll just go ahead and reconnect.